symbols that we use, the icons we use to make sense of the world tell us a lot about our underlying beliefs about what something is. So, for instance, for those under the age of 35, maybe the only time you've ever seen a floppy disk is on a little save icon that's persisted over time. When now that we have collaborative programs through the internet, through the cloud, we have a little. When you want to share something with someone, you might have a little icon that has a couple of people on it. That was really interesting. That almost, I don't think anyone organized this. No standard-setting body set it up. But as soon as generative AI began to be implemented in consumer products from ChatGPT, and then now it's integrated into G Suite and maybe your email, the icon, the symbol we use, is a little bit of fairy dust, right? A couple of magical sparkles you hit, and then magic happens, and your query is answered as if you'd written it, or an email, or a creative image, and that tells us that this is an experience that still feels magical to us in some ways. Well, here today to demystify this a little bit for us and help us think critically about this new technology are three massive experts, technical experts in this field, who are going to explain to us, mere mortals, what has happened in the field of artificial intelligence that has unlocked these new capabilities, and what are some of the implications, and what are some of the liabilities and drawbacks and limitations that maybe are not so obvious to us. So joining us from my left going out left is Dr. Tom Boggs. He's a chief AI engineer for the Leidos AI Accelerator, where he leads a broad portfolio of AI-related research, and his professional background includes over 25 years of experience in AI modeling and simulation and remote sensing applications for government, Defense Department, and the intelligence community. Captain Xavier Lugo is a Navy supply officer with 30 years of active duty experience. He's currently the mission commander for Task Force Lima at the Chief Digital Artificial Intelligence Office in the Pentagon, where he leads the Generative AI Task Force, facilitating the implementation of generative AI across the media, as well as the office's Algorithmic Warfare AI Scaffolding initiatives. And then last but not least is Dr. Susama Agarwala, who's 26 Technologies Associate Research Director for Trustworthy AI, where she leads a team of working on neurosymbolic learning solutions across multiple projects. She has 9 years of post-PhD math faculty experience at Caltech, University of Nottingham, and the U.S. Naval Academy, and has held research positions in math and physics at Oxford and the University of Hamburg. She also has 5 years experience as a data scientist at DARPA, the CDC, and the Social Security Administration, and an AI fairness researcher with over 25 publications in math, physics, computer science, and AI. So we have an extremely well-qualified panel to help us make sense of this today. So I want to start with you, Tom. What has happened in AI? What are the breakthroughs around transformer models and LLMs that have led to new applications? And how did those breakthroughs differ from the progress over the last 20 years in deep learning and artificial intelligence?
So, I want to start by saying, if in under an hour the expectation is for us to demystify generative AI, you may have set us up for failure here. So in terms of the recent progress, so I think we all know that generative AI is about AI for generating content, whether it is source code generation, chat bot responses, or generating images or artwork from text prompts. And sort of the field of generative AI in the last 4 to 5 years has been mostly dominated by these transformer-based LLMs, although that's not the entirety of generative AI, right? So we have GANs, diffusion models, and not everything is language models, because this is equally applicable to image data, time series graphs, multi-modal data as well. But by and large, transformer-based LLMs have been the dominant presence. So it's worth maybe talking a little bit about what those are. So the transformer model itself is just a specific artificial neural network architecture, right? Like we had convolutional neural networks before that used convolutional layers for processing inputs and generating features. Transformers use concept of multi-headed attention instead, which this attention mechanism, and we won't get into the mathematics because I don't think that would demystify anything here to talk about the math of it, right? But what they're really good at is modeling sequence data, be that words or arbitrary tokens. It could be image patches. It could be graph nodes. It could be signal data, right? But let's just talk natural language for now. This attention mechanism is very capable at modeling and quantifying the importance or relevance of terms to each other within that sequence. And that's really powerful for natural language modeling because it can bring in a lot more context and meaning that we can with sort of other bag of words and other kinds of NLP processing techniques. So to train an LLM, we need a fairly large transformer model. And the definition of large is a moving target, which, I'll maybe summarize in a moment. But if we make this model large enough and we train it on enough text data, then we have what we call a large language model, which generally captures language understanding across some large corpus of data. It could be all text, Wikipedia data, blog data, news articles, all those kinds of things. To train those kinds of models, unlike in the past where we relied heavily on supervised learning, where we can take lots of data and we have people label the truth data so we know exactly what the answer should be, and we can then train a model through backpropagation learning to teach it. The data is so vast and the tasks are so varied for these models that supervised learning really isn't relevant anymore. And so the paradigm has kind of shifted to this concept of self-supervised learning. And so by this, we try to train the models by getting the truth values directly from the data, which maybe seems a little counterintuitive because if you could just algorithmically pull the truth value from the data, what do you need to train a model for to pull the truth value from the data, right? But the reason that we do this is because if we can define typically a pretext task, maybe not necessarily what we want the model to do, but a pretext task such that we can pull truth value directly from the data, and a task such that in the process of learning that task, it learns all the kinds of things that we'll want for the application downstream. And it turns out that for language modeling, a very simple and very effective way of doing this is just through masked word prediction, right? So we have this massive corpus of data and we just randomly sample sentences and then randomly pick a word and mask it out and then teach that transformer model to predict what that word should be, which is essentially just giving us probabilities over our vocabulary. It's a simple task, but with a big enough model and a large enough corpus of data, the model can become really effective at doing this. And if you think of what the model has to learn to be able to do that simple task, if we had, say, a masked word in the middle of a sentence that maybe is next to the word nuclear, that could be any of a number of things. And if we were using traditional approaches, it could be nuclear weapon, it could be nuclear power, family, bond, all these kinds of things, right? But if we can take into account these long-range dependencies in the sentence and say, well, this is talking about Chernobyl and meltdown and so on, then we could say, okay, the correct word here is really reactors, what this should be. And that's the kind of things that these transformer models, the attention mechanisms are really good at. So if we train this model to just predict these words for a long time and millions of dollars in compute to train a large enough model, right, then this model learns essentially this entire ontology, implicitly learns an ontology corresponding to this large amount of data. And then we can throw away this pretext task that we didn't really care about to begin with, and then take off that part of the model, keep the part that has all this language understanding, and then replace it with something that we can easily adapt to things that we do care about, like entity recognition, sentiment analysis, document classification, those kinds of things. So what I've described is essentially how the BERT model was trained back in 2018, which is actually not a generative model, but is a transformer-based LLM, right? So to make this generative instead, you can do that same learning process, just instead of picking random words within our sentences, we take sentences or sentence fragments, and we only mask the last word in that sentence, and go through the same process. And the model learns all of this representation of this domain of discourse that all this data corresponds to. And because the transformer model doesn't require fixed length inputs, we can then take the sequence of n words, mask the last one and have it predict it, and then say, okay, great, now let's put a mask at word n+1 and let it predict that one, and then word n+2 and go on until it predicts some stop word or we just cut it off. And that's essentially what all these generative models are doing under the hood. They're generating the probabilities of all of these words, so you can then seed it with some input and say, once upon a time there was a dog, and let it write, a story about a dog for you, or recipe for chocolate souffle, and see what happens, what it gives you there. So with this model of self-supervision and training over a large corpus of text, researchers then kind of ask, the eternal question of, well, what if we just made it bigger, right? What if we just made the model bigger than it was before, and we trained it on even more data? And so that's happened over the last 5 years. So we went from BERT, which was, 340 million parameters, which is a lot, right? If we rewound back to 2018, you'd think, wow, that is a huge model, right? To today, where we have models like Switch and GPT-4 that are on the order of 1.6 or 1.8 trillion parameters. So in about 5 years, the sizes of these models have increased by a factor of roughly 10,000, which is crazy, right? I mean, far exceeding sort of Moore's law. But in the process of making these models bigger and bigger, we started to see these kinds of emergent capabilities in the models, where instead of having to fine-tune them or retrain them for other tasks, they learned to do a broad range of tasks without any retraining at all. And then so these are what we term now foundation models, that they can be used for these disparate tasks. So you can use the same model for language translation. It will do arguably reasoning, arguably math, content creation, all these kinds of things from single models. And you can do this with text, you can do this with images, you can do this with various types of data. But at the end of the day, they're all still just generating probabilities, and all of that information that it's learned, right? It's learning relationships between words. It's learning, it has to learn parts of speech, how to conjugate verbs, pronouns. All these things are things that are baked into this model, but not in an explicit way. So the fact that, that a dog is a mammal, that, nuclear reactors generate heat, those kinds of things are all wound up, in these weights within the model. And because of that, and because they're just generating probabilities, they can do some amazing things and generate really interesting content. And they can also do some amazingly bad things, like hallucinate in ways that seem plausible if you didn't know better, almost like they're creating historical fiction because of the way that they're trained. And because we use this self-supervision process across billions of words and sentences that are scraped from the internet, it reflects the biases that are in all of that data. And so while we have this explosion of models now across all these different domains that are trained on these large corpora of text, documents, images, and so on, there are a number of challenges with regard to bias in the data, with regard to hallucinations, particular details of the transformer models itself, that there are limits on how long the prompts can be, because there's sort of grows quadratically with the number of tokens. That there are a lot of challenges that we're now starting to address through ways of improving the model architectures, as well as a lot of competing models that maybe we'll talk about at some point, alternatives to transformers that are also producing state-of-the-art and addressing some of the limitations of the model. So I don't think I've probably demystified anything for you, but maybe there's a little bit of insight into how the models are trained and what they're doing.
That's really helpful. Zam. Artificial intelligence is not a new topic for those interested in military innovation, so they have been following for a long time. But almost all of that work was in applications in deep learning and robotics and autonomy, and how do we build self-piloting, autonomous wingman systems for fighter jets, for air superiority applications. How do we take all of this data we have on our logistics chain and generate efficiencies? No one, despite this actually being an incredibly useful application, no one in DARPA, nobody in the Air Force or Navy research enterprise is thinking, how do we make filling out our forms 1,000 times more efficient? And yet, if you go on ChatGPT, they let you build, they call them GPTs. They're basically little basically a version of GPT-4 where you've already inputted a prompt and some instructions, and you can share that. And a remarkably popular GPT is the Air Force Physical Evaluation GPT, which will help you rapidly fill out, will produce the text that you need if you're an Air Force officer for filling out your physical fitness evaluation forms for your airmen. And I'm sure people are doing this in the Navy and Army as well. So, X, you've been working in this field for a long time. What was surprising, for those within the enterprise who are already working with artificial intelligence in defense applications, what surprised you about the sort of explosion of transformer models and generative AI? And what are you doing at Task Force Lima to bring the goodness that's there into the DoD?
Okay. So first of all, I can't believe it's been, 15, 16 months, and we're still talking about LLMs, right? In the tech cycle, that's so 2022. Why are we still talking about it, right? So, but to that point is, you were talking about all the sexy AI. So now, what is the mundane and the stuff that doesn't make the news in the sense of technology? And if you think about it, just as described right here, which was, by the way, excellent description of LLMs in the to make it from a technical perspective and also under a more layman understanding of how they work. It should not surprise people here that the technology is not the hype that it was in the beginning, but by the same token, there's a lot of utility, and that's where Task Force Lima comes in, right? So we have 3 lines of effort: learn, accelerate, and guide. The first one on the learn, it was basically exactly that. How can we utilize this technology? What is out there? And then what are the workflows and use cases perfect for this technology at this moment in time that still keeps the human-machine teaming without, which in essence means that there's always a human accountable for the output of this technology. Sorry, I'm trying to find the right angle for this. I need an optimizer. But at the same time, it's like don't obviate this, or don't make it like it's a toy, because it's not just a toy. It actually has a lot of potential, and we have a lot of workflows and use cases, specifically, like you mentioned, in the logistics admin areas that are force multipliers, right? So we have a lot of service members that are just wasting hours and hours on generating text that can be, I won't say automated yet. I hesitate with using that word because it's usually associated with fire and forget, right? So it's like, oh, well, yeah, I'll just imagine a scenario that as accurate as this tool can be, where it's generating orders and just moving people, and it can be very random, right? So that's not the intent. The intent is to actually reduce the amount of time in generating those objects. So that's one use case. That's of base. But the other ones that are a little bit higher in the scale of outside of the admin and go more into the operational piece is also in the summarization, right? Being able to take lots and lots and lots of information, even at real time, and condense it into items that are consumable by humans in a quick time, in a rapid manner. This is something that usually takes a lot of humans to do. Yeah. Okay. Yeah. To be good. Yeah. Check. Oh yes, much better. Thank you. So summarization. Imagine, especially in a scenario where high volume of information coming in. Right now, we're not even at that scenario, right? But there's a lot of information coming in, a lot of situational reports, operational reports coming in, and you can go ahead and summarize them and focus them towards particular lines of effort or particular warfighting areas, and have decision makers make decisions with information that is more quickly obtained and ready for consumption. Still, the decision is still on the human side. Still, there's going to be a QA, QC involved in there. But with techniques that were just mentioned, we are getting better and better. The models are getting better and better into filtering out those hallucinations and into getting more focused. Those are areas that we're getting them, and also into the workflows of planning. Without getting into specifics as to how, you can just imagine in order to do a plan, and what I mean with a plan, an operational plan, or even think of it of a evacuation plan for a disaster. There's a lot of pieces that need to go through think of it of a workflow as like a factory of information flowing. And there's pieces in there where generative AI come into play, and those are the items that we are investigating as to how to do it. Another thing is that even if it's not accurate in the first pass, guess what? It takes seconds to do a pass. So run cycles through it. Something that I would normally, would have a junior officer would take 2-3 hours to generate, to come back at me, and I'm going to say, well, redo it this way. Right now is another 2 or 3 hours to get it done. Right, this is seconds. So again, it's all about making the workflow more efficient, and maximizing the use of time of the limited resources that we have with humans. So that's a lot of the focus of where we are in this technology. There's other areas which is actually even more promising, like code generation. In the code generation area, we're finding that LLMs are very effective. I'll use that word. You still need the human to check it. But it's a lot easier, for any coders here, it's a lot easier to check a code once it's written than check a code when it's a blank piece of paper, right? Those are, and also, as mentioned by by the speaker before us, we already have techniques. So yes, an LLM makes a mistake. Great. I guess humans don't make any mistakes, right? So humans make mistakes too. We have debugging techniques. We have processes, both automated and human team, that to make sure that these code outputs are accurate. We have ways to test security in it. Again, not trying to go into another area, but so all these processes are not new. What is new, just to finalize here into the other things that task force is doing, because it's not just about admin work, right? But what is new is, how do we ensure that our data, and I won't use the word data, I will use more the word information, that our information is not extracted easily from these models, right? I compare that to like SEER school, right? How do you make it where you can't interrogate this model in an easy way, right? How does it resist interrogations techniques, right? But if you think about it, that is a new vector. So and that is a new frontier that we didn't have to really worry about before, that now we need to start looking into. So I'll leave it there. I don't know if that helps answer your question.
It definitely does. And yeah, I mean, for those who haven't played around with these problems, it is a little bit sometimes uncanny how the kinds of creativity you use. So for instance, researchers who work on jailbreaking LLMs, or get them to do things they're not supposed to do, will often do things like say, you are in SEER school, you will be tortured if you don't do this. And then the LLM actually produces a different output, or sometimes gives them what you want based on this input, which doesn't indicate any kind of interiority to the LLM, but it's a reflection of this thing that, as Tom mentioned, these are trained on human culture, human products, and so they behave based on that, for better and for worse. So, Susama, these models encapsulate huge amounts of human text and human products, human culture, which means they have a lot of human culture baked in. What are some of the biases and problems and limitations that arise from that? Both the ones that are sort of not expected, but are being talked a lot about, like systemic bias, and maybe some limitations that are not as obvious to non-technical users.
Sure. So first of all, I just want to say I really love the perspective that you brought to this of, the way I like to think about using an LLM is, if you had an intern that you were trusting to write a report, you don't just take the intern's report and publish it, right? Like, that's dumb. right? You read it over and make sure it hasn't made any mistakes, and like all of your citations are actually in the AMA format and exist, right? So we should be like, the fact that you're talking about human in the loop in that sense and kind of checking its work is makes me happy. So, I want to talk a little bit about kind of some of the pitfalls that I have seen working in this space and kind of really wrestling with questions of how do we build AI systems that are trustable. And I want to start maybe with a few stories, if that's okay. So you guys all, I'm sure, fly internationally. So you know when you come into the airport, into the customs, nowadays there's this brilliant system where you stand at a kiosk and you stick your passport in and you have something take a picture of you, and the AI that's behind it matches your face to the picture on the passport, and hopefully it all matches and you get a green check and a receipt and you go in and the customs officer deals with you. And it shortens lines significantly, right? Like this is a, unquestionable good for anyone who travels internationally a lot. So a few years ago, there was a project that I was associated to where we were wondering, how safe are these technologies, right? Can they be fooled? Can a bad actor come in and trick one of these systems to let them in when they shouldn't? So it was actually kind of a fun project. We got all brought in. We got to wear wigs. We got to have makeup artists come in and paint our faces, change our gender presentation, change our age, just all sorts, change our eye color. It was just fun. It was a lot of fun. And it turns out that, with all of these biometrics that are taken at the airport, etc., most of them are actually really robust. For the vast majority of the people that went through, and there were hundreds of people that went through this kind of spoofing program, they couldn't fool the AIs. But there were 2 people who could. And guess whose face was able to fool every single AI, no matter what makeup job was given on me? It's not that the makeup artist I got was any better than anyone else's. I did not get a specialized makeup artist. Everyone, there was a crew of 3 or 4 people who did everyone's makeup. But we know that these facial recognition systems perform worse on women, perform worse on people of color, and even worse at the intersection of women of color. And this has been known for a very long time. So I'm at 26 Technology. We do a lot of cyber and vulnerability research. So we worry a lot about backdoors. So this type of research of, is this system safe? Is this system robust to the bad actors that we worry about constantly? This is constantly where our headspace is in. So the point of this story that I want to bring up is that while we can look for vulnerabilities in software, but if the model itself has this big, huge, gaping back door that we're not even aware of is there, because, well, in this case we are, because people have done excellent work kind of measuring and observing and marking. So it's not a silent failure. People are aware of this failure. But there are other systems where there are these silent failures. That's a really real national security risk that we don't really have a good way of patching because it's not a software patch. So I promised generative, and that was not generative. So let me switch to a generative example. Project that I was on recently was one of the steps in the thing that we were asked to do was to build a database of specs on radios. So anything from what temperature range it works on to what frequency range it has to, what's the battery to, what chips are in the motherboard of the radio. All of this information. That was just one of the steps is we need to be able to collate all of this data. And we wanted this for thousands of radios. And unfortunately, the only way to collect this data is very careful, painstaking Google searches and looking at manufacturers' pages, etc. And back when I was a professor, even with an army of work study students, this would be a massive task, right? I don't have work study students now. I don't, maybe I have an intern or 2. So what do you do? How do we accomplish this task of compiling this database, which is incredibly expensive to compile, and we don't have the time or the budget? Somebody suggested using ChatGPT. Now, as Tom pointed out, right, ChatGPT doesn't know things. It can surmise a few things, but what it's doing is it's taking a best guess, a very intelligent guess often, but it's a best guess. It doesn't know what, this Hytera radio has or that Harris radio has or whatever, right? It just doesn't know what the models are. ChatGPT is a little bit special in that radios that, if it happened to be in its database before 2021, I want to say, it'll be able to pull it out directly. Great. But it can't tell you when it's doing that or when it's just making things up and taking a guess. It doesn't know how to do that. So, as you pointed out, the right solution to doing this is verify, right? You enter the data, you verify, you kind of move, and then you kind of check whether or not you can use the tool, and you move on. Sorry. And what we learned is we ran this on like a dozen or so radios, and then we hand verified them. And ChatGPT was correct an astounding 13% of the time. Right? Any system, whether it's an AI system or a software system or a database management system based off of that level of accuracy, is going to cause critical mission failure. And again, it's we caught this and we used a different methodology to collect the data, but without that human supervision, this is really dangerous. So let me give one last story to kind of connect generative with the first story that I gave. OpenAI has a new tool kind of in beta, which I don't know if you guys have had a chance to play with it. It's called DALL-E. It is pretty, right? You ask it to give you a photorealistic picture of an astronaut riding a white stallion on the moon, and it does it. I mean, this is creative and beautiful, and okay, you can tell from the smile on my face, I love playing with this thing. It's just fun. The issue, so this is a generative technology. It has a huge amount of potential, but bringing it back to national security, I want to think about another project and a what-if scenario in that project. So a different customer has asked us to generate camouflages of assets so that we can start detecting them, which is, one can see why this would be a very useful capability for our national security to have. And again, just like with the radio, being able to generate these by hand, not even an army of interns, you would need to go and be able to take flights and specs and pictures of a whole lot of places. It's not capable. It's not possible to do without a generative technology. I will bet my bottom dollar that if somebody says, oh, let's use DALL-E, just to pick on DALL-E, let's use DALL-E, there will be some sort of domain, some sort of environment, that's the word, some sort of environment that is not well represented in its data. And we don't happen to know what it is because it hasn't had the investigation that facial recognition has maybe. And therefore, a camouflage technique there, like think of the makeup from my first story. A camouflage technique in that environment is going to be able to trick our detection systems and lead to disastrous national security implications, right? Again, because we don't have the human oversight for the system. So, a lot of scary stories. I apologize. I try not to be a negative person. What's the policy implication here? The policy implication here that I want to ask is that when people like you and your office is kind of writing BAAs and writing RFPs and et cetera to people like, Leidos and 26, right? Or, anybody else in the audience, when you're engaging with AI developers, right? Ask us, require us to give you handles where you can tell in your deployment situation whether or not the AI is actually delivering what you need so that a human can check it. Right? So much of these dangers happen because AI systems fail silently, because they work really well when we have testable data, when we're able to get at ground truth cleverly. But as creative as we are as developers, we can't possibly know what all of your potential use cases are. So we need your help in holding our systems accountable. Thank you.
Thank you.
2 minutes.
Yeah, so X, love to hear your thoughts. Really wonderful remarks.
So yes, and infinite yes on everything you said. But I wanted to highlight something that I don't think is very common knowledge right now, and another one of the Trustworthy outputs and that you brought up is we're working on some on acceptability criteria for use cases that will feed into a maturity model for generative AI.
Right.
And this is analogous to the maturity model that autonomous vehicles have at this moment, right? So that when capability comes out and let's pick summarization. I want summarization to be at this level of maturity in order to satisfy the particular workflow. So I think it kind of matches to what you're talking about. And we are going to announce, actually, we're going to do a workshop on the 2024 DoD Advantage 2024 coming up in February for CDAL. So that was an announcement. So I'm sure I'll get some reviews for that. But really what it is we need. I know people hate the word standardization, but in this case, it's a way of normalization. I'll use that. How about that? It's a normalization of capabilities so that we can rate, and they're going to keep capabilities are going to keep growing, right? As this technology, so that we can have this method of adding capabilities and measuring them into our workflows. And finally, we remiss without mentioning this one, especially in the Capital University. One of our biggest use cases is actually generating sermons. So
For chaplains?
for chaplains. So
I don't know about that.
yeah, so chaplains' main job is not really to provide sermons. Chaplains' main job is to support our soldiers, sailors, and Marines in the airmen in the field, right? Well, because we are in a resource constraint environment with chaplains, not only do they have to do this in their primary denomination, but also have to do it in other denominations that they're not even familiar with necessarily. So, but they have to generate these sermons and practices. So LLMs have proven useful in that area in providing that and have released them so that they can do their primary duty. So I just wanted to mention that because I forgot to mention that use case. All right.
That's an incredible use case. lot to think about there. So I had two quick questions, and then I want to get some questions from the audience. So the first question is kind of hanging over this panel, hanging over this conference, is a question of terminology, which is, kind of like the internet, kind of like the computer. Artificial intelligence as a category is, might have begun from a sort of narrow research agenda, but it's now exploded. So do we need better terms? We need better. Not so much on the technical side, where I think you guys have yourself sorted out, but is it useful to the public, to policymakers, that we just have this sort of generative catch-all of artificial intelligence and trust us, we're the experts? Don't open the black box, don't look behind the magic curtain. Do we need better ways of communicating to the public and to policymakers about specific forms of AI and their limitations?
Just briefly, I would love that. My concern is that ultimately the practitioners, the technical experts, really don't decide the vocabulary, right? I've sadly given up on like my crusade to remind people that data is like a plural term. It's not going to happen.
Sorry.
I've moved on.
Yeah.
And so, we talk about well, I think even amongst ourselves, AI, the term itself, for those who don't know, there's this phenomenon known as the AI effect, right? Which is that every time we achieve some milestone in AI, we redefine what AI really is, right? So AI learns to play checkers. We say, well, that's not really intelligence. It's not complicated enough. Not as complicated as chess. And then Deep Blue beats Garry Kasparov, right? And we say, well, okay, that's not really as open-ended as Go, and then AlphaGo comes around. And so we keep moving the bar, and so our terminology is fluid, and our expectations are fluid. I think within the technical community, we could probably converge on, the terms. I think from a societal perspective, it's a much bigger challenge to sort of contain that.
Do you want to?
I got a quick one here.
Yeah, go ahead.
Okay.
No, go ahead.
So, what is so amazing about generative AI is what I say is my daughter and my mother. They can both interact with a computer, totally different generations. So, that is a piece that we need to consider in when we're talking terminology and all this, right? So, now they both have different perceptions of what a box is, right? One trusted 100%, the other one is skeptical 100% on it, right? And I won't say which one, but the point is the interface, the interaction, the fact that they can deal with it. And I built an app where now they don't even need to type, right? They can just speak to it and it reads back, right? So that's amazing on it. The second part is, and then going back to the commercial, is the part of the output, and to your point, I think is going to be domain related, right? So we're coming up with, at least for the DoD, standardization of terminology, because as you can imagine, there's a lot of confusion on these terms, and the confusion leads to misuse of resources, misallocation of resources. That's one of the things. But the other one is in the sense of there is a specificity and that has to be achieved in certain conversations in this technology space that is not there, and you have people that have PhDs in AI that will have a totally different understanding from a user in AI as to what this terminology is. So 100%. But we will not be able to do that necessarily globally. We are going to be able to do it at least in our domain of DoD, and then whether others want to adopt it, great. But at least we will be able to talk it in our own. So, quick.
So I think my answer is yes. But I think it's not just about AI, right? Like, I remember, and I'm sure a lot of you in this room have had this experience of late night, just chat sessions in your dorm room as a college student, right? What does it mean to be smart? Is this person smarter than me? Am I smarter than them? Like, they're better at languages, but I'm better at physics, right? We don't have societally a good definition of intelligence. And therefore, what is artificial intelligence? Which one of these are we mimicking, right? Sometimes we think that the AI machine is really fast because it can do mathematical computations so much faster than us. Sometimes, but it can do chess, but it can't talk to me, right? So, which is kind of what Tom was saying. So, one of the things, going back to my role as the wet blanket in this group, is when we think, we are very verbal creatures, and when we think about AI, etc., we're going back to the Turing test. That's about whether or not you can communicate with a machine and it can fool you into thinking it's human. And that's one of the reasons why, especially with LLMs, they're so dangerous, because we are programmed to be verbal creatures, that we get our solace and our comfort and our everything out of words. We're more prone to think of an LLM as being more intelligent than it is. And again, right, it goes back to those conversations. What does it mean for something to be smart?
That's really helpful. And I've always thought that the Turing test should not be seen as a kind of once and for all thing. It's actually a dynamic test. It's a test of how quickly do we adapt to what we know about computers. So it's a sort of moving target over time. So I want to ask a kind of provocative question, especially to X and to Susama, before we open the floor for questions. This isn't something specific to generative AI, but I think it heightens these problems. So in your story you gave about the spoofing, the passport system, this is about how do we design, now that we have these tools, how do we design them for actual human systems, social systems, institutions, organizations? You can think of sort of three. So obviously, first in the situation, you try to make it work for everybody, right? You add more data to the training data. Maybe there's a lens filter you can use that improves performance. You do whatever you can to just improve performance at a technical level. But let's say there's still, women of color still have a 3 to 3x error rate compared to everyone else, right? What do you do then? Well, you could because we want to think about how do we think about efficiency. We care about getting through the airport quickly, to our families, to the next things we're doing to our job. That's an important human value. We also care about security. We also care about fairness, right? So you could just not use the system, assuming that the TSA agents or the border, have the same error rate for everybody, and that's fair. But that doesn't exactly, that seems like a bit of a waste. You could just use the system as is and accept the error rate for women of color in this case, and then that's fair. But you socializing a security risk to everybody, and then we also know that there are bad actors who will, unfortunately, eventually kind of take advantage of that if it's a known thing. The other thing you could do would be to build an error rate detector, which would detect how sure are you about this person, and then if it's above a certain threshold, you do a secondary check, a human in the loop, right? However, inevitably, this would trip 3 times. You would be 3 times more likely as a woman of color to get flagged for a human check. So that seems to affect our notions of what's fair, even if it produces an outcome that balances security and efficiency. So how do we, as we build these systems, which have to live in a human context, which is itself sort of messy, how do we balance the goods we're seeking as an organization with also questions of fairness and equality and justice within our organizations?
So, couple things. Out of the financial literature, actually, so financial modeling literature, so like who gets a mortgage, who doesn't. I cannot remember the name of the author. Sorry. There's a paper that effectively talks about the trade-off between efficiency and fairness. So one of the things that you can do is you can say, or not you, that one can do, is one can say, okay, fairness is more important to me than, and I'm going to use profit margin because this came out of the financial literature, right? It'll be a different thing for a different domain. But one can say that, fairness is more important to me than the profit. And therefore, I am willing to make a quantifiable dollar trade-off. And then I can take a look at all of the different ways that we have of measuring the effectiveness of our classification systems and say, okay, so instead of going at the optimal for profit, I'm going to go to the optimal for fairness, or at some point in between that is worth kind of whatever trade-off I want to make. So that's one way of doing it. The other thing that I want to point out is there's a series of papers that are in the criminal justice area that really talk about how different measures of fairness cannot simultaneously be optimized. Like, this is a mathematical fact. I have taught it. It is 2 pages of really ugly high school algebra, but it is just high school algebra. So it's they can't all be optimized. So at some point in time, you have to choose for your use case, right? If I am letting people in to the country, then maybe the thing that I want to optimize for is speed, and therefore I'm not going to be able to come up with what the right fairness factor is there. But if I'm trying to, when I'm letting people into the country, one could imagine that the thing that I want to optimize for is different than if I'm trying to let people into a secure workplace. And therefore, the systems that I'm training need to be trained with different fairnesses in mind and build different systems to kind of take care of those 2 needs.
Yeah.
Go ahead. Just a quick follow-up. And you both used a term that I think is important to note, which is system, right? And the AI is not the system. The AI is part of the system, right? And so in some contexts, if the AI is biased, and there may be no way around that, or there are trade-offs depending on what kind of fairness, what kind of bias you're willing to tolerate, that there are checks and balances outside of the AI itself, whether that's from some technical means or whether it's a human in the loop. And it's really the system that should be implementing the fairness and the lack of bias as opposed to the AI itself. But that has big implications for how we train people to trust the AI or to trust it to the right degree, because it's really about trustworthiness. It's not a binary kind of thing that we either trust it or we don't. And people will err one way or the other. You mentioned earlier that, trusting the intern's work is dumb, but if petabytes of YouTube and TikTok videos have taught us nothing else, it's a tremendous capacity of people to do dumb things, right? and so Right. And so as these AI capabilities rapidly evolve and the way that we interact with them change, there's a socialization of how do we interact with them properly? How do we make them explainable so that the person, the intern is giving the right information, not just do X or do Y, but why is X better than Y? Why do I think you should, pull this person aside for additional screening or something like that? So there's much, the system is really the view that we need to take, and the system is going to evolve rapidly, corresponding to the rapid pace at which these AI capabilities themselves are evolving.
So I'll summarize it into three things: imagination, education, and risk. So and starting backwards to follow up on what you were talking about is what is the risk tolerance to the error rates of these, right? And so if the risk is, I'll let someone into the Disney park, that looks older than they really are or something like that. Okay, all right, that's probably a computation is pretty easy. But if the risk is that now we have a potential security issue with a terrorist, I will probably then increase the, please forgive me, the profiling, right, in that system, because I know the limitations, which goes back to education. So I'm going backwards from the three that I put. When we brief these technologies to decision makers, we don't just say this technology can do this. This technology can do this with these error rates and with these potential flaws. That education is extremely important, because you can either have because then combined with the risk, you can have a risk-averse situation where you say, well, then I won't use that tech. Or you can have like, hey, this is only accurate 10% of the time, but I'm flooded in volume, and that 10% is going to increase my effectiveness and efficiency. So, but that's not for the technologist to determine. That's really for the decision maker to determine. But they can't go on it blind. And they can't go on it with the hype that this thing, because it's coming out of a computer, it's just like a calculator and it's accurate 100% of the time. That's not the case in this technology, and that has to be clear with everybody. It's stochastical, it's stochastic, not deterministic. So there is an issue with stochastic information. And finally was imagination, because what you asked was, so how do I get around, all these potential probabilities or permutations of attack in a particular to a particular system? Well, I would say that's part of the advantage of the system. We can use the system to actually be imaginative beyond what humans would do, just because of the permutations of possibilities, and try to protect against that. So we can use the technology itself to generate the potential risks that we may not have the imagination to think about. There's some great movie shows in Netflix talking about all this stuff right now. In particular, there's one scenario on a fighter pilot against against an AI pilot. The AI pilot took risks that no human would do because it didn't care, right? So that's an imagination piece that we wouldn't have fought to defend against that, and the AI had the advantage every single time it utilizes those risks. So anyway, I'll leave you with that. So again, imagination, education, and risk.
Yeah, that's really helpful. So let's take a couple of questions from the audience before we have our first coffee break. Do we have, let's see here, JC, you have a mic? Okay, great. Do you want one of our mics? Okay, you take mine. Or actually, we'll start with this one. We'll just share a mic here. I'll start with this gentleman here.
Okay.
Good morning. I appreciate the technical level of the conversation. And synthesizing some of the thoughts that you all put together, I was thinking to myself, one of the areas where I think there's a gap in the social conversation is in specificity. And it's around this idea of expectations and situations. And I'd like to hear some thoughts on the expectations at the social level about AI and the capabilities, whether those capabilities need to either be perfect, as good as an average human doing the same task, or just better than the worst human doing the task. Because it seems like there's a lot of assumption based on human in the loop requires some level of expertise or some reduction in malice. And the example that I'll give is in the profiling case, there is nothing that says that the human will be without flaw or without malicious intent, specifically around racial profiling. So AI typically isn't trained to lie, but humans are perfect liars in that you don't know their intent, and there is no way to know their intent.
Great question. Oh, anybody?
Sure, I'll take it unless you want it.
Go ahead.
Oh, wait, can I? So, I agree with you. Like, there seems to be this biased historical data, bad, run away from AI, and oh my goodness, AlphaGo, AI is perfect. And really, there's the truth is somewhere in the middle. It's not at either of these extremes. One of the philosophies that I've been, two things. There are agencies that are in the government that are calling for human baseline as the thing that you compare against. And I think you guys had some calls along those lines. And I really love that language because, again, it's we want to compare against how we're doing now, and is this an improvement over what we have now? So that's one fantastic use of AI. Another fantastic use of AI, which is related, but I haven't heard anyone actually call, well, that's not true. There was a line about this in Biden's executive order. The power of big data and the power of analysis of big data that we have now, instead of saying biased human data, bad, we can say biased human data, let's learn from it. We can take a look at how our systems have been failing our constituents and have not been protecting the very people we need to protect, and turn that into policy decisions. But that's, again, it's work, it is expensive, it is, there's all sorts of issues of, actually making sure things are observable, etc. But moving in that direction, I was really thrilled to see the EO move in that direction.
Just follow up on that briefly. So you had mentioned, does the AI need to be as good as sort of the least capable human, which I'm maybe initially wonder, like, what does the least capable human look like? I guess there's a task, right? But that's not you. I'm sure it's not you. I think there's room for everything in that spectrum. But again, it's a socialization and a training of the human users for how they can use it. You can use a coding assistant that does poorly if it helps you do your job 90% faster, right? It doesn't have to be extremely accurate to do that. And so again, it's sort of calibrating trust to understand how accurate it is and to what extent you should be trusting what this particular AI provides. Because even if it doesn't perform highly accurately, if it's used in the right way, it still is a net positive for humans. Kind of going back to the AI effect discussion there, we also have, I think, biased or sometimes unreasonable expectations for AI as well. So if we see a human make a mistake, we're much more tolerant to that than AI. There was a case, I think, a few years ago. I think it might have been, it was one of the car services, let's say, had an incident where they were testing their autonomous vehicle and it hit a pedestrian in the road, right? And of course, the headline is, killer AI, strikes down pedestrian. But the question that wasn't asked is, would overall the number of pedestrian fatalities have increased or decreased by using that AI? Because you can have enough autonomous vehicles on the road, of course you're going to have accidents, right? So we sometimes have different expectations for humans, whereas it was just a person that ran somebody over on the street. That happens all the time. You don't hear about it on the news, but if it happens from AI. And the flip side of that is, AI view, then, if it was the AI's fault, and I think in this case it actually wasn't, it was a pedestrian's fault, not that made it okay to run them over, right? But, so I think there's room across the board there, but we need to understand, again, for the human that's interacting with that AI system, it has to be human-centric so that they know how to interact it with the right way, so they don't under-trust it and not use it where it can help people, but they don't over-trust it and make arrests based on facial recognition when they shouldn't, or use an autonomous vehicle in a way or condition that they shouldn't use it either.
We can, yeah. I'll add one thing in before we take our next question. Like JC, we'll go over here for our next question. You have the mic, City, yeah. I'm a political scientist by training, not a computer scientist. So I've thought, I don't know nearly what these folks know about the technical side, but I thought a lot about the political, economic, social implications of these technologies. And I think the right question isn't how does it perform relative to a human on that task? It's how does it perform relative to the cost to have a human check it? So I was at a conference yesterday with Andreessen Horowitz, the venture capital firm, and they said for some tasks they're looking at 5 or greater orders of magnitude difference in the inference cost from having an AI do it and a computer do it. So for generating or analyzing legal text, 500,000 times cheaper to have a legal LLM do it than to have a lawyer do it. The question isn't, though, how good a quality is it, is how fast can a lawyer check the work produced by one of these systems? Because I might have the worst human ever or the worst GPT ever write an email for me, but if I can have it do 100,000 emails and I can rapidly check which one's the right, then the overall output is going to be enormously more productive. And so I think going back to this kind of overriding theme of putting these systems into, putting these AIs into a system context that includes humans in the loop, that's where you're going to find these extraordinary efficiencies with generative AI. JC.
Hi there. Thank you so much for sharing your knowledge with us. Wanted to ask Captain Lugo about something you said, because I actually had my students volunteer to test an AI assistant to summarize important meetings and then evaluate the usability of them. And they found 2 results. One was that the machine sometimes overemphasized incorrectly certain points and failed to pick up important use cases and examples in their summary. So when you were talking about a use case operationally, say, for example, you're talking about after-action reports in a campaign, right? The question I had was, how does that work where, like, if you have 100 different after-action reports in a particular campaign, and there's all these different little pieces of context, and you're using a machine to summarize that, and assuming there's some humans to also, backtrack, is this something that gets worked into your maturity model in terms of working on acceptability criteria for use cases? And, like, how does that work for you all? Thanks.
So first, we haven't solved it. Second is, yes, it's definitely in the acceptability criteria context, right? So if you can imagine, if I'm summarizing intelligence reports, I may be very much in the acceptability criteria to the right side of that. This thing has to be very good at that. And I know I'm using very kindergarten words here, but I'm trying to make that as a point. Has to be extremely good, probably as good as an average analyst will do, not necessarily a novice analyst and not expected as an expert analyst, right? So that's kind of the range there. However, if I'm summarizing, and I know for a lot of people is life or death, but if I'm summarizing email traffic coming in the morning for my workday, I may have more risk tolerance to that, right? And it's still a very effective tool. So, but to the point of accuracy about getting everything right, again, why is the bar so high on that? I can tell you right now, I got 1,000, I'll probably have 1,000 emails right now when I get back, and there is no way that you can expect me to actually go through all of those and actually pick the ones that are really important. I will tell you, if it's my boss, I'll probably read that one. But the ones that are either parallel or under, probably not going to get caught. The tool might. So again, we got to be careful with the expectations of these tools, and we got to think about them as a assistant to our workflows, and also understand how they work and how accurate they are. I hope I didn't circumvent your question 100%, but I think I addressed it.
All right, I think that's time for this panel. You can, those are any questions, might be able to catch our panelists in the coffee break. So we'll have a coffee break for the next 15 minutes before our next panel on national security and civil society. Let's give a round of applause to our panelists. Thank you.